Hey folks, we're going to take a look at fatty acids. And fatty acids are like a building block used in a lot of different lipids. So we're going to just kind of focus on what is a fatty acid, what does it look like, and how do we name it and such, and then use it in other parts of this module. Now, fatty acids are naturally occurring monocarboxylic acids. And so if we were to take a look at the structure of a fatty acid, it looks basically like this, where we have our carbonyl group like this, okay, and then coming off like that. Okay, so here's our carboxylic acid portion, and then there's this tail that comes off like this of just carbon atoms. So this right here is our fatty acid. And our fatty acids in nature, naturally produced ones, tend to have even numbers of carbons. So if I were to number this here, I would say, well, here's C1, 2, 3, 4, 5, and 6. So an even number of carbon atoms, that's what we see in natural ones. And we have names for these, just kind of general categories based on the number of carbon atoms. So we have long chains, medium chains, and short chains. So our long chains here, so long chain fatty acids, so I'm going to go fatty acids. Long chain fatty acids, these tend to have 12 to 26 carbons. So I'm going to go C12 to C26. Okay, and then we have our medium ones. Medium chain fatty acids, and these tend to be 8 to 10 carbon atoms in length. And then we have our short chain. Our short chain fatty acids, and these tend to be 4 to 6 in length, carbon atoms in length. Now, you might be looking at this and go, well wait a minute, what about 7 carbon atoms in length, Professor Locken? 7, is that short or is that medium? Ha ha, ha ha, I laugh at you. Because they're even numbers. Remember, even numbers. Pay attention. We can organize these into other different types of groups here. We could call them saturated or monounsaturated or polyunsaturated fatty acids. So like this here is completely saturated. Remember way back when we started this class and it was in the depths and the grips of winter and such maybe. Saturated. So this one right here we would call saturated fatty acid. Fatty acid. Saturated fatty acid. That is to say we can't put any more hydrogens on there. We have all single bonds here in our carbon chain. So this is a saturated fatty acid. Now if we were to throw in a double bond on this here. So I'm going to just kind of erase this here a little bit like that. And I'm going to make a double bond here like this. Okay, like that. So now I have like this. I'm going to go 4, 5, 6. Okay. And so now this one here becomes a monounsaturated fatty acid. Monounsaturated fatty acid, okay, monounsaturated fatty acid. And if we have more than one double bond on there, so if I put another one on here like this and go like that, okay, making my zigzaggy lines now, and I'm going to go 7, 8, 9. Whoa, wait a minute, I can't do that. We got to make those even. Okay, I'm going to go down like that. There we go. There. Now we've got even numbers there. And there's 10. Okay. Right, did I do that right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So now this one here becomes a polyunsaturated fatty acid. Polyunsaturated fatty acid. And a couple of things to point out here on this is in nature, these bonds here, they tend to be cis. So I'm just going to make like a little arrow here and say cis. Yep, they tend to be cis in nature. That's just the way nature likes to do it, and I've learned a long time ago, don't argue with Mother Nature. And then where do we find these things? Well, these ones here, these tend to be found in places like nuts. And our saturated fatty acids, these tend to come from animal sources. So if you're getting your fatty acids from your diet, I mean, that's where we get these things from, generally speaking, our dietary fatty acids. If you're getting it from animals, you're generally getting more saturated fatty acids. And if you're getting it from plants, they tend to be more unsaturated, okay? And we have found that there's greater cardiovascular risk here in our people that consume lots of their fatty acids from animals. Okay, so there's a kind of an association there with that. Okay, so now let's take a look at how do we name these things. So like, what is the structure for these things? So kind of scratch this out here a little bit. Okay, and let's go and make this here. I'm going to make a big long one here. I'm going to make us a big long fatty acid. So we'll start out here like this here. We're going to go carbonyl, double bond O, and then OH like this. And I'm going to go, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so 2, 3, 4, 5, 6, 7, 8, 9, double bond. Okay, 10, 11, 12, double bond. 13, 14, 15, double bond, like this, okay? And I'm going to put in some numbers here like this. Here I'll go 1, 2, 3, 4, 5, 6, 7, 8, 9, 8. That's an 8. Oh my gosh, that's terrible. That's a pukey 8. There, that's much better. 10, 11, 12, 13, 14, 15, 16, 17, 18. All right. Whew. All right. We ended up with an even number, so I feel good about that. And I did this not to just try to prove to you that I can count beyond 10 without taking my shoes off, but how we name these things. So most of these fatty acids have common names, and that's because naming them is a little bit of a mess here. So we could call this here as a carboxylic acid, and it has here, so this would be a triene, and then there's 3 double bonds on there and such, and they end up with a big, long, ugly name. Okay, and that's a bit of a nuisance. So there's kind of a chemical shorthand for this. What we do is we count up all the number of carbon atoms, and we call this thing 18, because there's 18 carbon atoms. That makes it easier, right? As opposed to calling it like octodeca something triene, right? And so we're going to go 18, and then we're going to put a 3 here, and then that 3 tells us that there's 3 double bonds. And then those double bonds are located. We put a delta symbol here to say that they're located after carbons 9, 12, and 15. So superscript 9, 12, and 15, like this. So this is just kind of like the chemical shorthand here for naming these fatty acids. And again, they've got common names, but this just makes it a little bit easier. Now, I'm going to give you another example here of two other fatty acids using a different way of looking at them, and that's counting from the other end. So here I'm going to do, let's see, I'll do carbon, double bond oxygen, OH like this, and then we'll go here, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, like this, okay? And then I'm going to draw one more here. I'm going to go C double bond O, OH like this, and then I'm going to double bond like this, okay. Now both of these ones here are carboxylic acids, okay? They've got the long carbon chain here, making them fatty acids. And we notice that they are different in the number of carbons, but they are the same in where the double bond is when we count from this direction. Okay, so if we count from this direction, we would say that this one here, this one has got 6 carbon atoms. And if we come from the other direction, going this way, this is omega, we would call this an omega-3 fatty acid. Omega-3 fatty acid. And then this one right here, this would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this would be 10 omega-3 fatty acid. And you're like, well, why would you want to count them going that direction? Well, just give me one rule and keep it simple. Well, there's a number of sources where you end up seeing this structure repeated, where you would have, counting from this direction, the same structure. So like omega-3, omega-3. And you might be saying to yourself, wait a minute, I've heard of omega-3 fatty acids before. Maybe somewhere. And it's true in that omega-3 fatty acids are found in fish. And so I'll just go like this for right here. Found in fish. Okay, and specifically found in deep water cold fish. And is like, well, who cares? Well, people, like I said, they found out that people that get their fatty acids from animal sources tend to have higher incidences of cardiovascular risk. And they looked at populations around the world, and then they found, wait a minute, there's people in like North America, these native populations that eat a lot of animal fat, like seal blubber and such, and they don't have higher risks of cardiovascular disease. And they're like, well, that's kind of weird. What's up with that? Well, they studied these people, and they found that they're getting a lot of their fatty acids from fish, specifically these deep water cold fish like mackerel and tuna and herring and salmon have lots of these omega-3 fatty acids, okay? And that seems to lower your risk of cardiovascular disease, as opposed to omega-6 fatty acids. So omega-6 fatty acids, these tend to come from other sources, maybe plant sources, and these ones are associated with higher cardiovascular risk than say, fish sources. And so it's recommended now that you consume one serving of fish that's high in omega-3, so a fatty, cold, deep water fish, once per week. And you're like, well, that sounds fine, but you know, eating salmon once a week is kind of spendy. That stuff ain't cheap, and that's true. And what we're also finding out is there's such a demand for omega-3 fatty acids that these fish are getting fished almost to the point of extinction. And so science has stepped in, and we started collecting omega-3 fatty acids from other sources, like from krill and algae and such, and then putting them in these pills. And chemically, it's the same thing. You just don't have to kill fish to get them. Now, one other place you might find fatty acids, which is kind of interesting, is champagne. Now, champagne has a very complex flavor, a lot of different notes and smells and tastes and such. And this is due in part to the fatty acids associated with champagne. Now, the dry and metallic notes of champagne come from dodecanoic acid, which is a fatty acid with 10 carbons in it. This decanoic acid here kind of gives it kind of a toasty, a little bit of an acidic taste to it. And then here we have ethyl mysterate. Now, ethyl mysterate is an ester, which we talked about earlier, but that just kind of gives kind of a sweet, waxy aroma. And then palmitic acid here, this is a kind of waxy and creamy aroma. This has got 16 carbons in it. So this would be a hexadecanoic acid. It's a big long word there. And then there's palmitoic acid here. This kind of gives champagne an oily and a waxy aroma here. And so this one here, we would say that coming from the right, this would be coming from the right, that would be a 16 like this, delta 9, 16-1 delta 9, 16-1 delta 9 fatty acid. Or if we were to go from the other direction, we might call this a 16-1 omega, 16-1 omega, we call this a 16-1 omega 7 fatty acid there. Okay. All right. So now, hopefully from this, folks, you have an idea of the structure of fatty acids, a little bit about how we name these fatty acids, where we might find them, and then we're going to use this knowledge here to apply them, these fatty acids, to lipids throughout this module.